Assalamualaikum. My name is Nur Akmal Hanis and today I will present you about atomic structure. Before we go through more about atomic structure, let me tell you two fun facts about atoms. The first one, there are over 100 different kinds of atoms and 92 of them occur naturally while the remainder made in labs. And the second one, the first atom was made by a man and named it as technetium, which has 43 protons. So this is my table of contents. There are 5 contents they include in my presentation for today. The first one is what is atomic structure, subatomic particles, development of atomic model, atomic structure, and the last one, isotope and its use. Okay, atomic structure is the structure of an atom comprising a nucleus, a proton, and a neutrons. There are also negative charged particles called electrons that revolve around the nucleus. So the first one is what is atomic structure? So let's get through about it. Primarily, the atomic structure is made up of proton, electron, and neutrons. So the neutrons and protons make up the nucleus of atom structure, which is surrounded by electron of that atom. So totally, the electron will surround the nucleus that contain neutrons and protons. So the neutral atoms number equal to numbers of protons and electrons. Or there are some info I want to tell you. Some atoms may gain or lose electrons to increase their stability, and this resulting charged entity called as an ion. The second one is subatomic particles. So in this content, we will know more detail about subatomic particles that contain in one atomic structure. First subatomic is proton. Proton is known as positive charged particle in atomic structure. Symbol for proton is a small letter of P, while the relative charge is positive 1 since it's a positive charged particle. So the relative mass is 1. You should know that protons are over 1800 heavier than electrons, and total number of atoms equals to the atomic number of one element. So the number of atoms is equal or same as the atomic number of some elements. Second subatomic is called as neutron. Neutron is a neutral charged particle in an atomic structure. So basically, neutrons are electrically neutral particle and don't have any charge. So the symbol for neutron is a small letter N. Relative charge is 0 and the relative mass for neutrons is 1. Subatomic in atomic structure called as electron. So basically, electron is a negative charge particle in atomic structure. So the symbol for electron is E, while the relative charge is -1 since the electron itself is a negative charge. So the relative mass for electron is 1 over 1840. So the third one is development of atomic model. So we all know that atoms can be neither seen with naked or microscope since the atom itself is a very small particle. So in 18th and 19th centuries, many of scientists attempted to explain the structures of atoms with the help of atomic models, but there are many scientists try to explain the atoms with the atomic models, but the most notable contribution to the fields were John Dalton, J.J. Thomson, Ernest Rutherford, Niels Bohr, and James Chadwick. First one is John Dalton. John Dalton theory have been used from 1766 until 1844. So John Dalton said that matter is made up of particles called an atoms. An atom is the smallest spherical body that cannot be created, destroyed, nor divided further. So, same elements have the same atoms. So, the pictures show the Dalton's atomic model. Dalton's atomic theory have been demerits because of the theory itself was unable to explain the existence of the isotopes. The second one, nothing about the structure of the atom was appropriately explained. Second one is J.J. Thomson. J.J. Thomson theory have been used from 1846 until 1940 only. So basically, J.J. Thomson have discovered two new things in an atom, which is electron with negative charge, and an atom is positively charged sphere with a few electrons in it. So the picture shown the Thomson atomic model, which contains electron and positively charged matter. So J.J. Thomson theory also demerits because Thomson atomic model does not clearly explain the stability of an atom. Also, further discoveries of other subatomic particles couldn't be processed inside his atomic model. So the next one is Ernest Rutherford. Ernest Rutherford theory have been used from 1871 until 1937. So he found nucleus in the center of an atom. He also discovered positive charged particles called a proton. And so the wall of atomic mass concentrated in a nucleus. And Ernest Rutherford also found electrons move outside of the nucleus. So this is the picture of the Rutherford's atomic model. So the limitation of the Rutherford atomic model is if electrons have to revolve around the nucleus, they will spend more and more energy, and against the strong force of attraction from the nucleus, a lot of energy will be spent by the electrons, and eventually so they will lose all their energy and will fall into the nucleus, so the stability of the atom is not explained. This is Niels Bohr. Niels Bohr's theory have been used from 1855 until 1962. So Niels Bohr theory actually simple that I have found. Basically, he found electrons in an atom move in shells around the nucleus. So basically, each electron have been located in each shells and move around the nucleus. Last one is James Chadwick. James Chadwick theory have been used from 1891 until 1974. So James Chadwick has discovered neutral called neutron in the nucleus. So he said that neutrons contribute almost half of the mass of an atom. So in Chadwick's atomic model contains proton, a neutron, nucleus, and electron. So after we know all about the development of atomic models, let's go through the atomic structure. This is the standard representation of an atom. So X is symbolized of chemical symbol for the n element, while L is the mass number, which equal A equals Z plus N, while the Z is atomic numbers equals to numbers of protons. So in atomic structure, there are two different types of structure. The first one is atomic structure itself, and the second one is in electron arrangement. So the first one is atomic structure. So what is atomic structure? Basically, atomic structure shows the number of protons and neutrons in nucleus in the center of an atomic structure itself, and electron arrangement of an atom. So the picture shows the atomic structure of chlorine atom. Atomic structure of chlorine have different type of shell. The first one is the nearest one with the nucleus called as K shell, while the second one is L shell, while the third one is S. So the second one is electron arrangement. What is electron arrangement? Electron arrangement basically shows nucleus and electron arrangement of an atom, and it didn't show the numbers of protons and the neutrons in nucleus. So basically, we should know that electron arrangement shows the name of element in the center of nucleus, and each shells have different number of electrons. Thirdly, we are finally in the final contents, which is isotope and its uses. So the meaning of isotopes. Isotope is an atom of the same elements with the same numbers of protons but different neutrons number. In the picture, we can see that there are three types of carbon, which have different neutrons but the same number proton, and because of that there are different masses of each type of carbon. So, the relative atomic mass of isotopes. So, most elements exist naturally, a mixture of two or more isotopes. And natural abundance is the percentage of isotope present in natural sample of element. So, this is the formula that we can be used to calculate the relative atomic mass, which is this one. So the last one is uses of isotopes in our daily life. So basically, this is my example of isotope that we use in our daily life. So I will tell you three about it. So the first one is cobalt 60. Cobalt 60 basically a radiation therapy to prevent cancer in a medicine. And the second one is iridium 192, which is to test the integrity of boiler and aircraft parts. And the last one is phosphorus 32 and phosphorus 33. So basically, this phosphorus is used in research involving biology and genetics. So that's all from me. Thank you for hearing my presentation, and thank you so much for give your ears and eyes to see me present. Thank you so much. Assalamualaikum.